In this video, I'd like to cover some properties and examples of covalently bonded molecules. And in this case, I'd like to do a reminder. We said that covalent bonds are formed when molecules or atoms share valence electrons. And when we have valence electrons being shared by different atoms of different or same elements, they form covalent bonds. And we have an example of hydrogen molecule. Now, each hydrogen has one electron in the valence shell, and to obtain a duplet state configuration or a duplet state stable configuration, each hydrogen will contribute one electron to the shared pair. Now, when we have this hydrogen contributing this dot and this hydrogen contributing this cross, the type of bond that is formed between the molecule is called a covalent bond. Now, we normally have a representation of a covalent bond, and in this case, I may be having hydrogen molecule. Remember, I said that hydrogen contributes one electron, this one contributes one electron. The two electrons can be represented by a single line. So whenever you see a single line in a molecule, that one represents a covalent bond. Now, we have different types of covalently bonded structures or substances, and these tiny things are represents water molecule. This is how we may represent water molecule as a substance. Now, in this other hand, I am having diamond, and other examples of covalently bonded substances are gases, liquids, diamond, graphite, and others. Now, we have different types of covalent bonds. Now, we normally have single covalent bond, we have double covalent bond, and triple covalent bond. Now, in terms of shortness or the length, triple covalent bond is normally shorter as compared to double and single covalent bond, and that is why the triple covalent bond requires a lot of energy to break as compared to the preceding two. Now, let us try to do some examples of common diagrams of covalently bonded structures, and in this case we did one for hydrogen. Let us try one for water. Now, oxygen atom contains 6 valence electrons, and that is where we're having these dots 1, 2, 3, 4, 5, 6. Now, the dots are from oxygen. Remember, oxygen requires only 2 electrons to obtain the octet state, and that is why each electron from hydrogen is given to or shared to oxygen. That is why each hydrogen contributes 1 electron, each hydrogen contributes 1 electron, and oxygen shares the 2 electrons, and it makes sure that this molecule becomes water. And in case we try to count the number of electrons in terms of obtaining stable configuration, we will realize that oxygen now is stable and hydrogen is equally stable. Now let us have a look at ammonia. Ammonia contains 1 nitrogen and 3 surrounding hydrogen atoms. Now, ammonia has 5 valence electrons. Now, when I talk about valence electrons, I mean the outermost electron that an atom of an element has. Now, these crosses are for nitrogen. That is why we are having 1, 2, 3, 4, 5, and the dots represent hydrogen. Now, nitrogen requires 3 electrons to be stable, and that is why it needs 4 hydrogen contributing 1 electron each. Let us have a look at methane. Methane contains 1 carbon surrounded by 4 hydrogen atoms, meaning the valence shell of carbon is containing 4 electrons, while on the other hand, hydrogen only contains 1. So all the 4 electrons in carbon will be shared with the 4 hydrogen atoms, and all the 4 hydrogen atoms will give 1 electron to be shared to carbon, and all these atoms obtain a stable state configuration. Now, I'd like you at your own free time to try for hydrogen chloride and chlorine gas. Now, further, we have types of molecules like ethane, carbon dioxide, or carbon oxide, we have ethanol and ethene. Similar procedure. Ethane contains 2 carbon atoms joined together and surrounded by 6 hydrogen atoms. It therefore means that each carbon atom will be surrounded by 3 hydrogen atoms. Now, this carbon, let us take for example, it has 4 dots, the valence electrons. Now, these 4, 3 will be shared to hydrogen, and equally, the 3 hydrogen gives 1 electron to the shared pair. And 1 electron from this carbon is shared to this other carbon, and that is why we have these 2 carbon atoms having these 2 electrons that they share. Equally, the same thing happens in this side, and it leads us to formation of an ethane molecule. Now let us have a look at carbon 4 oxide. Carbon 4 oxide has 1 carbon and 2 oxygen surrounding these carbons. Now, carbon has 4 valence electrons, that is why we have these 4 crosses. Now, the oxygen requires 2 electrons to be stable. Why? Because oxygen has 6 valence electrons, meaning this carbon will contribute 2 electrons to be shared to this carbon, to this oxygen, sorry. This oxygen will be given or contributing, this carbon, sorry, will contribute 2 electrons to be shared with this oxygen, and that is why we have these 2 crosses here. Now, each and every oxygen will contribute 2 electrons to the shared pair. Remember, we can also represent the cross and dot with a single line, and that is why we'll have 2 lines here, 2 lines here, in case we were supposed to write them in terms of lining. Now let us have a look at ethene. Ethene molecule is C2H4. C2 meaning 2 carbon atoms and 4 hydrogen atoms. It therefore means that we'll be having 2 hydrogen atoms in each carbon atom, and each hydrogen will be contributing 1 electron to the valence, to the shared pair, and this carbon and this carbon each will contribute 1 and 2 electrons to be shared, and we will obtain such a molecule. At your own free time, you can try to draw for ethanol. Now, we have types of forces between molecules, especially when you talk about covalent bonds. We have different types of molecules, and examples of molecules we're having are liquids and gases, and they have very low melting points and boiling points. Now, let us have a look at this structure of water molecule. Now, between the hydrogen and oxygen in the water molecule, we have strong covalent bond. But between one molecule to another molecule of water, we have very weak van der Waals forces, or we call it weak intermolecular forces between the 2 molecules of water. But don't forget that between hydrogen and oxygen, we have strong covalent bonds. But between one molecule of water to another molecule of water, we have weak van der Waals forces of attraction. Now, when we heat water, say solid ice, the weak intermolecular forces of attraction are broken or separated by the strong heat energy. So the bonds are broken that hold the molecules together to form a liquid, and on further heating it forms a gas. Now finally, in terms of relative strength of bonding interaction, intermolecular forces, or rather the van der Waals forces of attraction, are the weakest, and covalent bonds are the strongest, and that is why we are having the hardest known substance called diamond, and diamond is a strongly covalently bonded substance, and that is why we use it to manufacture drill bits that we go and mine in the fields. That one brings me to the end of this short tutorial. Make sure you subscribe to the channel. Thank you. Bye.